Darkness seeps in as the hatch of the submersible seals shut. The metallic groan echoes downward, a warning: from here on, there is no turning back. Through the thick glass window you watch as the ocean opens before you, vast, silent, and utterly unknown. The ocean covers more than 70% of Earth's surface, yet we've explored only a fraction of it. Down here, where light never reaches, strange sounds ripple through the water with no known source. Massive stone structures rise from the seabed like the ruins of forgotten civilizations. Entire stretches of water glow for hundreds of miles in the dead of night. And in some places, sonar sends back nothing at all. Tonight you will dive deeper than ever before, carrying a list of the ocean's greatest unsolved mysteries. From the booming Bloop that once shook the Pacific to the submerged pyramids of Yonaguni, from seas that glow like milk to regions where compasses spin wildly without direction, every one of them is waiting for you in the dark. But remember this: when you call the ocean by name, it answers. And sometimes, you'll wish you had never heard its reply. The Bloop, a voice from the deep trench. You are invited to a remote NOAA hydroacoustic station in the South Pacific. The request is simple: help reanalyze an old recording from 1987 using their new array of hydrophones. They call the sound the Bloop. It is famous, infamous even among oceanographers, a low-frequency boom so powerful it was detected by sensors thousands of miles apart. If it came from a living creature, that creature would be larger than any whale ever known. The idea of going down there into the black water makes you hesitate, but curiosity wins. The control room is ice cold, illuminated by the pale glow of spectrum analyzers. A map of the Pacific fills the main monitor. The coordinates lie far from any landmass, deep in a patch of ocean that sailors call nowhere. The waveform stretches across the screen over 1 minute long, far stronger than typical seismic tremors or iceberg cracks. It almost feels deliberate, as if something wanted to be heard. A veteran technician leans over your shoulder and mutters, "It's not ice, it's not quakes, that's why you're here." You run the recording through the station's new noise reduction algorithm. Under the rumble of currents and distant tectonics, a faint tail of sound emerges, barely audible, but undeniably structured. It rises, dips, and rises again like breath, like a voice too large to comprehend. You glance at the technicians, but they are silent, watching the same lines on the screen. To triangulate the source, the team deploys an additional set of hydrophones deeper into the trench. For hours you wait, listening to the hum of electronics and the slow tick of the clock. Then an alarm. One of the new sensors picks up a return signal, but the coordinates are wrong. It's not coming from the abyssal plain miles beneath you. It's coming from directly behind the vessel in open water, where nothing should be. The crew rushes to the deck. The sea is flat, silent, utterly empty. But the sonar keeps pinging, closer, closer. You stare at the monitor as the blip approaches, certain that at any moment something will rise from the darkness. But nothing breaks the surface. Only the quiet hiss of the wind and the soft slap of waves against the hull. Shaken, you dive into old NOAA archives. There were other unexplained sounds upsweep recorded in the same ocean basin, a rising tone anomaly that repeats seasonally. Slow down, as if something massive were decelerating against the sea floor. Each event clustered near the same lonely coordinates. It's as if something has been traveling through the Pacific for decades, speaking in a language only the deep can translate. Around the table, the debate begins. Icebergs calving under pressure. One scientist insists, pointing at frequency charts. Perhaps massive sheets of Antarctic ice breaking apart, resonating like a drum. Another suggests biology, an unknown leviathan, a creature so large its calls would dwarf the songs of blue whales. A third theory whispered, rather than spoken aloud, artificial. A machine, a beacon, something that has been down there far longer than we have had the means to hear it. That night, long after the crew has turned in, you sit alone in the control room, staring at the waveform frozen on the monitor. Suddenly, the ancient spectrum analyzer flickers to life on its own. A low, deafening pulse fills the room, the exact frequency of the bloop. Your heart pounds. This time the signal is not coming from the trench. It is not coming from the open ocean. It is coming from the deck above you, right behind the steel hatch. Up you sweep the staircase of sound. You barely sleep after the bloop. By dawn, a new request waits on the mission board. Another anomaly, another sound. This one they call upsweep, a rising tone signal that has been recorded in the Pacific since 1991. It comes and goes, with the seasons sometimes fading for years, only to return without warning. You join the maintenance crew tasked with checking a fixed network of hydrophones near the anomaly's source. The ship sails toward a vast expanse of open water, hundreds of miles from any coastline. By nightfall, you find yourself staring into a horizonless void. The ocean here is impossibly still. The first transmission arrives just after midnight. A low tone begins deep in the noise floor, climbs higher and higher, then abruptly cuts off, as if it has reached some invisible ceiling. A technician whispers, "It's like a staircase of sound." The display confirms that the upsweep pattern is perfectly intact. When you drop a temperature probe into the trench below, the readings spike in strange ways. The water hundreds of meters down is warmer than expected, as though something massive were radiating heat from beneath the sea floor. One of the crew, an old navigator, mutters that this region sings at the end of every year. You ask why. He doesn't answer. You request the entire array be synchronized, combining every channel of audio into a single feed. What you hear makes the hair on your arms rise. There isn't one source. There are two alternating back and forth like a call and response. Then something even stranger happens. The entire bank of warning lights across the console begins to flicker, not randomly, but in rhythm matching the rising pattern of the upsweep. The ship's electrical system seems to pulse in time with the sound. For a brief moment, you feel as though the vessel itself has become part of some immense machine, its heartbeat tied to something deep below. You order the sensors pulled up, but the system refuses to disengage. The displays freeze, then flash all at once. A log entry appears on the main screen, though no one touched the keyboard. 000, exactly midnight. Suddenly, the upsweep ends. Every instrument goes dead silent. The water around the ship is still as glass, as if the ocean itself is holding its breath. Back in the lab, the team debates theories. Some insist it must be geological magma, shifting undersea superheated water, forcing its way through hydrothermal vents, the planet's own plumbing moaning as pressure builds and releases. Others argue that it is biological, a vast school of unknown creatures, perhaps that migrate through this trench in perfect synchrony, broadcasting their presence with ultrasonic clicks and groans. But a third idea emerges, one that no one says aloud at first. What if it's not natural? What if upsweep is a beacon, a timer, something ancient and mechanical left behind, buried beneath the crust, waking only when a hidden clock strikes? Just as you begin to power down the equipment, the speakers erupt with one final tone. A single piercing upsweep, louder than any before, rattles the walls of the control room. You glance at the ship's clock. The hands tremble, then settle. Exactly so, midnight again. And then silence. Slow down, the sound of something halting. Sleep does not come easily after the upsweep. The next mission drops on your console only hours later, another unexplained anomaly. Its name is almost mocking in its simplicity. Slow down. First recorded in May of '97, the sound lasts 7 full minutes, a descending wail that lowers in pitch as though something massive is decelerating through the ocean. NOAA analysts pin the event to waters off Antarctica, but no one has ever seen the source. Your vessel heads south toward the edge of the frozen continent. The temperature plummets. The wind slices through your clothes, and the sea grows rougher the closer you draw to the ice shelves. The old navigator from the upsweep trip joins you again, and his only comment is, "This one is worse." The first hours pass quietly. Then, as the ship nears a jagged wall of ice, the sonar feed explodes with activity. A long, low moan fills the speakers, falling in pitch deeper and deeper until it vibrates the walls. It is exactly the signature of slow down. You launch a multi-beam sonar sweep under the ice. The result makes no sense. Beneath the shelves lies a vast, shapeless, acoustic shadow, a place where the sonar returns are swallowed instead of reflected. It is like staring into a black hole. Then the tension ratchets higher. One of the cables suspending a sonar array tightens sharply, then goes slack as though something down below had pulled at it. The crew hauls it up in silence, but before the winch can lock, a noise slides through the speakers, a rasping, grinding sound that mirrors the slowdown tone, only closer. Your hands tremble as you cross-reference old logs. There have been other detections of this anomaly in previous years, scattered along the Antarctic currents. Each time the sound would slow until it abruptly ceased, never recorded again until months or even years later. The theories come fast and defensive. Some say icebergs calving slowed by friction as they ground against the seabed. Others argue the calls of some unknown marine life, perhaps a behemoth that uses frequency sweeps to navigate the polar depths. And there are those who murmur about machinery, something ancient so large and powerful, it could only be detected in its final moments of movement before stopping. As you analyze the latest recording, you notice something buried in the lower frequencies. It is faint, just a whisper, but the pattern is unmistakable, a rhythm slow and deliberate, almost like breathing. You lean closer to the speaker as the noise resolves. One long exhale, then another. You realize with growing dread that the final breath does not belong to the sea. It is right next to the hydrophone, only meters away. The sound cuts out. The monitors return to silence. And in that silence, for the briefest instant, you swear you hear the echo of something alive turning away. Julia, a whisper in the ice fog. The silence after slowdown lingers like a weight on your chest. The crew is shaken, but the next assignment comes quickly. Another sound, another mystery. This one was first recorded in '99 and named oddly Julia. The NOAA brief is simple: travel south again, this time to the edge of the Antarctic Circle, and try to capture Julia in higher resolution. Analysts describe it as a guttural moan, lasting more than a minute, loud enough to be detected by every hydrophone in the South Pacific at once. Your ship pushes deeper into the polar sea. The air is thick with fog, the kind that clings to your skin like frost. Temperatures drop so low that your breath crystallizes. At times, the GPS drifts as though something is interfering with the signal. The navigator frowns. "We're drifting off course," he mutters, adjusting dials that don't seem to respond. The first contact comes at dusk. A rolling, drawn-out groan slides through the speakers, echoing across the ship. The pitch is different from slow down, less mechanical, more like a voice calling from beneath the ice. The crew falls silent, listening. You triangulate the source using the full array, but the data doesn't match expectations. Julia isn't coming from the deep trench where the analysts predicted. It's shallower, closer to the undersides of the ice shelves. You lower a remote probe through a narrow fissure in the flow. Its camera descends into a world of milky water and ghostly white walls. Then the signal flickers. Lines of static streak across the feed. And in that static, a strange vibration pulses through your headphones like syllables whispered too softly to understand. Your hand shakes as you rewind the tape. Could it have been a word? You think you hear something, a syllable broken apart by static. Leah. The temperature probe begins to beep uncontrollably. The water is far colder than it should be at this depth, nearly at the freezing point of salt water. Yet there are strange plumes of warmer water rising from below like breath from an unseen mouth. The theories are hurried nervous. Some say Julia is simply a massive iceberg fracturing beneath its own weight, resonating through the Southern Ocean like a bell. Others whisper about unknown animals, giants lurking under the polar shelves, their voices too deep for human ears. And there is a darker suggestion, one no one wants to say aloud, something trapped, something calling for release. As the crew prepares to haul the probe up, every speaker on the ship erupts at once. The Julia sound floods the control room louder than ever. It's no longer a distant moan, it's close, it's right under you. The decks vibrate as if something enormous is brushing against the hull. The sonar display flashes a shape, an impossible mass, stretching hundreds of meters, but then the image vanishes. You yank the probe up through the fissure in the ice. For a moment you're sure something is following it, but the line jerks free. You stumble back onto the deck, clutching the dripping cable in numb hands. The ocean is still. The fog presses in tighter. Somewhere beneath you, the last echo of Julia fades into the black water. And for the first time, you wonder if these sounds are not just anomalies, but messages. The moving seabed, the ocean that breathes. The voyage north takes days. You are relieved to leave the ice behind, but the next assignment is no less unsettling. This time, the anomaly isn't a sound. It's a phenomenon that military sonar operators first documented during the Second World War, what they called the deep scattering layer, or the false bottom. You've seen the reports. Each evening, sonar would show the ocean floor rising hundreds of meters only to sink back down at dawn. It confused submarines, hid vessels, and even appeared to swallow torpedoes. But scientists now believe it's not the seafloor at all. It's something alive. You stand in the sonar room as the ship drifts above one of the largest trenches in the Pacific. The sea is so calm it looks dead. The first pings return normally, mapping the trench below. Then just as the sun dips under the horizon, the seafloor begins to climb. At first it seems impossible. The display shows the bottom of the ocean lifting itself upward as though the world were inhaling, hundreds of meters, then more, until the false floor is so close it's practically under the hull. The technicians scramble, adjusting frequencies. The layer appears to ripple to avoid the sonar beams, like it can feel you watching. Someone suggests deploying lights into the depths. A cluster of bright strobes is lowered, cutting through the black. That's when the feed goes dead. The sonar pings return nothing. It's as if the ship is hanging in a void, a bottomless pit of water with no floor at all. Whispers race through the crew. The older sailors speak of phantom beds they'd seen before, entire oceans that seem to breathe. You scan decades-old war logs. Destroyers in the 1940s reported watching the false bottom rise up and engulf submarines like a living net. Theories pour in. Biologists believe the deep scattering layer is formed by countless small creatures migrating vertically at night, fleeing predators in the upper waters. But the more you study the data, the more the pattern feels coordinated, too perfect, too synchronized, as though every organism were part of a larger whole. You stay at your console listening to the last faint returns on the hydrophones, and then you hear it. Not sound exactly, more like a rustling, a shiver passing through the water, building in volume until it's almost a roar. The hull vibrates. A crewman leans close and whispers, "Wings." But there are no wings down here. A sudden lurch throws you against the wall. The sonar lights flare back to life for a single frame. What you see makes your blood run cold. The deep scattering layer has closed around the ship like a cocoon. An immense undulating shape stretches as far as the sonar can reach. It's not scattering the sound anymore. It's absorbing it. Then as quickly as it appeared, it's gone. The seafloor drops back to its normal depth, as though nothing ever happened. The ocean is silent, but you swear you can still feel something brushing past the hull unseen in the darkness. Bio twang, the strange strings of the deep. You barely have time to process the moving seafloor before the next anomaly appears on the mission log. This one is newer, first recorded only a decade ago in the Western Pacific. They call it bio-twang, a bizarre metallic twanging sound unlike any other known marine noise. The assignment is simple: capture a clean sample and determine its source. But nothing about the ocean is ever simple. The ship drops anchor near a deep trench, a place so remote it has no official name. The water is flat and featureless under a moonless sky. You stand on deck as the hydrophone array is lowered, the cable hissing through the winch. Then you wait. Hours pass before the first bio-twang call arrives. It begins as a low hum, then snaps upward into a vibrating twang, almost like a guitar string plucked far underwater. The sound is powerful enough to rattle the hull. Your instruments flicker. For a split second, every sensor locks up, frozen by some kind of interference. The sonar screen goes blank. Then, as suddenly as it started, the system clears. You compare the frequency pattern to known species. It shares some traits with dwarf minke whale calls, but the match is imperfect. The pitch is too clean, too precise, as though generated by something not entirely biological. You ask the crew to replay the latest call at half speed, slowed down. The bio-twang seems almost deliberate: 5 rising notes, a pause, and then 5 notes again. A sequence. Theories circulate. Some argue it's a new species of whale, or another baleen giant, its vocalizations misunderstood, because no one has studied it closely enough. Others suggest it's the resonance of the trench itself, an enormous geological instrument vibrating in response to tectonic shifts. But one member of the crew leans in close and whispers the theory no one wants to voice. What if it's a signal? You brush it off, but the thought lingers as you sit at the console, headphones pressed tight to your ears. At 3 a.m., the bio-twang returns, louder, closer. The sound slams into the hull like a physical blow. The deck vibrates beneath your feet. You race to the sonar screen, but this time, there's no scatter, no false bottom. Instead, a single sharp spike climbs up the display and stops directly beneath the ship. The cable holding the hydrophones trembles violently, as if something down there is pulling at it. A deep, drawn-out twang echoes through the speakers, stretching until the sound distorts and shreds into static. You grab the winch control and start reeling the array up. The line comes free, dripping with seawater, but the last few meters are slick with something else: thin, translucent filaments clinging to the cable like strands of glass. They glow faintly in the dim light. No one speaks. You bag the filaments for analysis, though you're not sure you want to know what they are. As the ship prepares to leave the area, one final bio-twang call bursts through the speakers. This time you recognize the exact frequency. It is the same pitch as the vibration running through the anchor chain. And for a moment you swear the ship itself is humming back. The Baltic Sea anomaly, the dome in the murk. The Western Pacific fades behind you, replaced by the frigid gray waters of the Baltic Sea. This next mission is different. It's not about a sound. It's about something that sonar captured in 2011, a strange, perfectly rounded formation resting on the seabed nearly 90 meters down. They call it the Baltic Sea anomaly. The ship's crew is on edge before the first dive. The Baltic is dark even at noon, and the water here is thick with silt. Visibility rarely exceeds a meter, but you've seen the sonar images: a massive dome-like structure with sharp angles unlike anything geologists expected to find. You descend with the first dive team, the cold pressing against your suit. The light from your headlamp cuts only a pale circle through the murk. Then the anomaly appears out of the darkness, an immense stone formation rising from the seabed, its curved surface slick with centuries of sediment. Your hand drifts across the rock. It feels wrong, too smooth, too intentional. Behind the main structure lies a deep gouge in the seafloor, a trench leading directly to the formation, as if something massive once slid into place. The divers fan out. One reports a strange magnetic reading, another says their compass is spinning uncontrollably. As you approach the top of the dome, your own instruments begin to fail. Lights dimming, comms crackling as though something is interfering with every signal. You try to document everything, snapping photographs as quickly as possible, but the cameras glitch images, distorting into streaks of static. Theories weigh on your mind even as you work. Could the formation be a natural glacial deposit shaped by retreating ice thousands of years ago? Or could it be something older, an ancient ruin swallowed by the sea? Some have even suggested it is a crashed object, a relic of technology lost or hidden long before recorded history. One diver calls you over to the far edge of the formation. Embedded in the stone is a deep vertical slit, narrow but straight. It looks almost like a doorway. You shine your light into the gap, but it is filled with blackness. Your instincts scream at you not to enter. Then the sonar feed from the support vessel comes through in a burst of static. The operator reports movement footprints, fresh depressions in the silt around the anomaly, but none of your team has been anywhere near that section of the site. As you ascend back to the surface, the water closes over the dome like a lid, sealing it away once more. The Baltic Sea remains silent, its secrets locked in the cold mud. But the image of that slit, that impossible doorway, follows you long after the dive. And you can't shake the feeling that something down there was watching. The Yonaguni Monument, the staircase. Under the waves. You leave the gray Baltic skies behind and head far south to the warm turquoise waters off Japan's Ryukyu Islands. The next anomaly has lured divers and archaeologists for decades. Discovered in 1986 by a local diver, the Yonaguni Monument lies only 25 meters beneath the surface, yet its origin remains one of the ocean's greatest unsolved riddles. Your boat anchors above a strong current that pulls relentlessly toward open sea. Visibility here is far better than the Baltic, but the water is restless, swirling with the energy of the Pacific. You double-check your gear and drop over the side, descending slowly toward the shadow rising from the seabed below. The monument comes into view piece by piece like a dream forming in the dark. Vast terraces carved into sharp right angles. Towering platforms connected by corridors that seem almost architectural. Steps, perfect steps, descending deeper and deeper, vanishing into the gloom. Your fins brush against stone as you swim closer. The surface is flat, almost polished, interrupted only by occasional notches and channels. One looks suspiciously like a carving, a series of deliberate lines etched into the rock. You trace them with your gloved fingers, wondering how currents and erosion could possibly create something so precise. The current suddenly surges, shoving you sideways into a narrow passage. Your headlamp slices through the darkness, illuminating what feels like a hallway, walls rising on either side. For a moment, it's as if you were exploring the ruins of some ancient temple. Theories spin in your mind as you regain control. Some geologists insist the monument is a natural formation, the product of sandstone fracturing along horizontal and vertical planes. Others argue the precision is undeniable, the work of human hands from a civilization long forgotten, perhaps one that existed before sea levels rose at the end of the last ice age. You swim up to a massive rectangular block at the edge of the structure. It could be a platform or an altar. A glint of something catches your eye near a crack in the stone. You reach in and pull free a small shard, triangular, smooth and sharp. It doesn't resemble the rock around you. You slide the fragment into your dive pouch, but the current surges again, dragging you toward the drop-off, where the monument falls into black water. Your dive computer chirps angrily. You've reached maximum depth for safety. You kick upward, heart pounding, the monument shrinking beneath you like a ghost. Back on deck, you empty the contents of your pouch. The shard is still there, wet and cold in your palm. It has strange markings on it, markings that don't match any known script. You ask the crew where the artifact might have come from. No one answers. That night, as the boat rocks gently on the surface, you lie awake and think about the staircases, the corridors, and that fragment now locked in the storage chest below deck. And you can't help but wonder what lies at the bottom of those stairs, hidden beyond the reach of light. Milky seas, the ocean that glows. The next mission feels almost like a reprieve. No ice shelves, no trenches miles deep. Just a strange luminous phenomenon in the Indian Ocean, first captured by satellite images in 2005 and again in 21. Mariners have whispered about it for centuries, calling it Milky Seas, entire stretches of ocean glowing white as if lit from below. Your vessel sails for days across calm waters, chasing a faint signature detected by orbital sensors. The night sky is clear when you finally arrive, and for a moment you think you've missed it. The sea is pitch black under the stars. Then slowly the glow appears. It begins as a faint haze along the horizon, like moonlight trapped in water. Minutes later, the glow intensifies, spreading until the entire ocean is a pale, ghostly white. The ship's hull seems to float on a vast sheet of glowing milk. The crew leans over the rails in awe. You lower a sampling bucket into the water and lift it out. The liquid in the container glows faintly in your hands. A quick analysis suggests a high concentration of bioluminescent bacteria, likely Vibrio harveyi. But the numbers don't make sense. The sample doesn't contain nearly enough organisms to produce such sustained planet-scale light. You send the ROV down. Its camera plunges into the glow, illuminating nothing but a vast, featureless expanse of pale water. There are no fish, no plankton clouds, just light. Theories race through your mind. Could this be a super swarm of bacteria somehow acting in perfect unison? A massive bioluminescent bloom triggered by unusual chemistry, but even that can't explain how the glow is so uniform, so stable, as though powered by something deeper. Hours pass. The glow shows no sign of fading. Then the ship's compass begins to drift. Electronics flicker. The hull groans softly, as if strained by an unseen current. A junior technician approaches you with a nervous expression. "You should see this," they whisper, handing you the latest satellite feed. On the display, the glowing patch of ocean forms a perfect circle, nearly 300 kilometers wide, and your ship is dead center. You consider leaving immediately, but before you can issue the order, a deep rumble vibrates through the hull. The glow brightens, searing white so bright it burns after images into your eyes. And then, just as suddenly as it began, the light vanishes. The sea is black again. The compass spins once, twice, then settles. You order a final sample taken, and the bucket returns filled with ordinary seawater, cold, dark, and empty. Only one clue remains. When you examine the ship's hull later, you find a thin film of pale powder clinging to the metal. It shimmers faintly when you touch it, as though it remembers the light. You scrape it into a vial, but a part of you doesn't want to analyze it, because whatever made the ocean glow like that may not have been alive at all. Black smokers, the breathing chimneys of the deep. The ship's course veers westward, carrying you into one of the most geologically volatile regions on Earth. This time, you're heading to a chain of hydrothermal vents, first discovered in 1907, known ominously as black smokers. From the surface, the ocean is calm and empty, but thousands of meters below, water superheated by magma blasts upward through fissures in the sea floor, carrying minerals that form towering chimneys of metal-rich rock. These vent fields are thought to be some of the most alien ecosystems on Earth, and possibly the cradle of life itself. You lower the ROV into the abyss, watching its camera feed as it descends. The water grows darker and colder with every meter, until the only light is the ROV's twin beams cutting narrow tunnels through the void. The chimneys emerge from the blackness like a city of monoliths. Plumes of superheated water gush upward, filled with minerals that shimmer like smoke in the artificial light. Tube worms sway in the chemical currents, pale and alien, thriving in a place where sunlight has never reached. At first, everything seems normal. The instruments report temperatures of 400 degrees at the vent openings, exactly what you expect. But then the readings flatten. No matter where you move the sensors, the numbers don't change. The system reports a steady, unflinching 400 degrees Celsius, even as the ROV's cameras show vent plumes intensifying. It's as if the environment has slipped into some strange equilibrium, a closed loop where nothing fluctuates. The chimneys begin to pulse on the monitor, slow and rhythmic. For a moment, it looks like the entire vent field is breathing. Theories from the surface lab flood in through your headset. Perhaps the ROV's sensors are malfunctioning, or maybe the chemistry of the vent fluids has reached a state of perfect balance, an impossible but natural phenomenon. But then the ROV's mechanical arm freezes mid-movement. The control stick in your hand goes slack, unresponsive. On the screen, the arm twitches once, twice, then retracts on its own as though something has taken hold of it. Your breath catches as the camera feed pans slightly downward. At the base of one of the largest chimneys, you see a hollow opening far too symmetrical to be natural. Something glints deep inside, reflecting the ROV's lights. A technician's voice breaks through the static, panicked. "Bring it up! Bring it up! Now!" You reel in the cable as fast as the winch allows. The ROV ascends its tether, jerking violently, as though something below is trying to hold it down. Then suddenly the line goes slack. The vehicle surfaces minutes later, dripping seawater onto the deck, but the arm is mangled as if crushed by enormous pressure. No one speaks as you inspect the damage. In the claw still locked in place is a fragment of black rock. But embedded in that rock is something stranger, a sliver of metal, perfectly smooth with markings too precise to be random. You place the fragment in a sample case, hands shaking. Some on the crew still believe hydrothermal vents could have been the birthplace of life on Earth. But as you look at that fragment glinting in the sterile light of the lab, a darker thought takes root. What if these places are not just the origins of life, but gateways to something older? The Dragon Hole, the bottomless blue. Your next destination takes you to the South China Sea, where turquoise waters hide a vertical abyss so deep it has earned a mythical name, the Dragon Hole. At over 300 meters, it is the deepest known blue hole on Earth, a yawning chasm plunging straight down through layers of ancient limestone. From the deck of the research vessel, the Dragon Hole looks deceptively calm, a perfect circle of darker blue within the surrounding reef. But divers who have entered its depths report an unnerving stillness, a sense that the water itself is pressing inward, swallowing sound. You prepare the ROV and lower it through the shimmering surface. The camera feed shows the vibrant coral reefs of the upper zone giving way to dim, green-tinged water. Fish dart past the lens, then vanish completely as the ROV crosses the threshold into the hole. At 100 meters, the water grows cloudy. At 50, it becomes opaque. The hole's layers are stratified by oxygen levels, creating pockets of dead water where nothing survives. The sensors begin to glitch as they descend, reporting inconsistent salinity and strange spikes in pressure. Then at 260 meters, the signal abruptly cuts out. You reel the ROV upward in frustration, assuming a hardware failure. But when the feed returns for a split second, you catch a glimpse of something that makes your blood run cold. A wall of darkness moving within the darkness, as if the water itself is alive. Theories swirl in the control room. Perhaps it's a dense layer of hydrogen sulfide, opaque enough to block the camera. Or maybe it's a collapsed cave system, the hole continuing deeper than any instrument can measure. You send down a replacement probe, this one equipped with a low-frequency sonar pulse. When the pulse is triggered, the water vibrates strangely, like striking a drum. The echo that comes back isn't random, it's rhythmic, a heartbeat. The probe's depth gauge begins to climb rapidly. 310 meters, 30, 350. The Dragon Hole is deeper than anyone imagined. Then the cable jerks violently. The probe is yanked downward faster than the winch can spool. You cut the line before it can snap, and the tether whips back onto the deck like a severed limb. Silence falls over the crew. The dragon hole is still. The perfect circle of blue ripples softly in the tropical breeze, betraying nothing of what happened below. When you review the sonar data later, you find the last pulse recorded at 370 meters. And over the waveform is a faint, steady beat too slow to be a fish, too deliberate to be a geological echo. You don't share that detail with the others, because if the ocean has a heart, you just heard it beating. The Brinacle, the ice finger of death. The next mission takes you back to the polar seas, to a frozen coastline where the wind cuts like knives and the water is black with drifting pack ice. This time you're here to document a rare and lethal phenomenon that few have ever witnessed. The Brinacle, a descending column of ice formed when supercooled salty water pours downward from the underside of sea ice, freezing everything it touches. From the deck you watch as divers descend through a hole sawed in the surface. You follow close behind the icy water, instantly numbing your fingers even through thick gloves. The world below is a labyrinth of jagged ice stalactites, the surface above a glowing ceiling of blue light. Then you see it, a narrow ghost white column extending down from the ice sheet, curling like a frozen tendril. It twists slowly as it descends, trapping brittle sea stars and urchins in its path. Anything that touches the Brinacle is flash frozen, entombed in crystal before it can escape. Your instruments show sudden, inexplicable fluctuations in salinity and temperature. The brine pouring downward is colder than expected, yet it pulses in strange intervals, as if something is controlling its release. You swim closer with the camera, careful not to disturb the delicate flow. The Brinacle splits into two branches, each spiraling downward like claws. One diver whispers over comms that it looks alive, like the fingers of some unseen hand stretching toward the seafloor. A muffled knocking sound reverberates through the ice overhead. Once, twice, 3 times. The divers exchange nervous glances. The knocks come again, this time in a steady rhythm. It's not the creaking of the ice, it's deliberate. Your dive timer flashes red, warning you to ascend. But just as you turn toward the exit hole, the Brinacle's branches accelerate, curling downward at an unnatural speed. One diver's fin brushes the icy plume, and in an instant the cold spreads up their leg like fire. You grab their harness and pull hard, hauling them toward the surface as the Brinacle snakes closer. You break through the hole, gasping, dragging the diver onto the ice. Their suit is brittle with frozen salt water, the leg inside already numb but alive, barely. Back on the ship, you review the data. The Brinacle's descent had followed a perfect interval, almost like clockwork. And the knocking, it had matched that same rhythm, resonating from deep below the ice shelf. You close the file and stare out at the endless polar horizon, because you can't shake the feeling that what you saw wasn't just an accident of physics, but a message. A warning carved in ice. Point Nemo. The ocean's desert. After days of sailing, you arrive at a place so remote, it feels like the edge of the planet. Point Nemo. The oceanic pole of inaccessibility, the farthest location on Earth from any landmass. From the deck there is only water in every direction. No ships, no birds, no radio chatter, nothing. The sky above is an empty dome, and for a moment you feel like you've slipped into another world entirely. Your mission is simple: recalibrate long-range hydrophones stationed here for deep space noise monitoring. But as soon as the ship's engines stop, you sense something wrong. The silence is oppressive, almost physical. At midnight, the hydrophones detect an unfamiliar signal, a faint, irregular pulse. It's not marine life, it's not tectonic activity. The waveform looks almost artificial. The crew gathers in the control room as you trace the signal's source. It seems to drift slowly beneath the ship, circling like a predator. Then the clocks begin to glitch. Every chronometer on board skips backward 7 seconds and then corrects itself. You glance at the navigator. Malfunction. He shakes his head. No, we've seen this before. Point Nemo is infamous for one other reason. It's the final resting place for deorbited spacecraft. Hundreds of tons of wreckage deliberately dropped here because no one lives within thousands of kilometers. But what if something down there is listening? You review satellite tracking data. The last spacecraft graveyard entry was years ago. Yet the sonar shows a ring of metallic debris scattered across the abyssal plain encircling something larger, something perfectly circular. The signal pulses again stronger this time. The hydrophones nearly overload. You switch the array to active sonar. The ping echoes down into the black, and for a long moment, there is no response. Then faintly a perfect circle beneath the ship far larger than any vessel, any wreck. The pulse stops. The ocean is silent again. But when you check the sonar log later, you find something chilling. In the final frames before the anomaly disappeared, the circle had shifted slightly, closing around the ship's coordinates. Like a noose tightening. The Antikythera wreck, the clockwork of time. You barely leave Point Nemo's emptiness behind before the next coordinates draw you into the Mediterranean, toward a rocky island off the coast of Greece. Here beneath deceptively calm waters lies a shipwreck that changed history, the Antikythera wreck. Discovered by sponge divers in 1900, the site yielded ancient statues, coins, and a mysterious device, an intricate mechanism of gears and dials that no one expected to find in a ship from 2,000 years ago. Some call it the world's first computer. Your team anchors near the jagged coastline. The sea is clear sunlight piercing down to the depths where the wreck lies like a broken skeleton. You descend slowly, the ruins coming into view, amphorae scattered in the sand, corroded bronze fragments half buried by time. The wreck is quiet, but as you approach the stern, you see something wedged beneath a collapsed beam, a corroded bronze panel etched with markings you don't recognize. You free it carefully, brushing away centuries of sediment. The panel is heavier than it should be, its surface studded with faint symbols that seem almost mathematical. Then your dive watch shudders. The minute hand skips backward, once, twice, then spins erratically before settling. Your depth gauge flickers, losing calibration for a full 10 seconds. You force yourself to ignore it and bag the artifact for analysis. But as you move toward the surface, the current shifts unnaturally, pushing you off course. The water feels denser, somehow dragging at your limbs. You break through the waves, gasping, the panel clutched tight against your chest. On deck, the captain studies your pale face and asks what you found. You tell them nothing because you're not sure yourself. Back in the lab, you compare the markings to high-resolution scans of the original Antikythera mechanism fragments stored in museums. They don't match. This piece wasn't recorded in any excavation logs, and the precision of the engravings is beyond what ancient toolmakers should have been capable of. A thought chills you as you study the panel's gear-like protrusions. What if the Antikythera mechanism was never complete? What if this fragment is one of many still scattered across the seafloor, waiting to be found and reassembled? Acoustic shadows, the phantom ships, the Mediterranean sun is still warm on your skin when the next orders arrive. This time, the mission takes you into the deep Atlantic near a continental shelf, where submariners have long reported ghostly radar returns vessels that appear on sonar only to vanish into nothing. They call the phenomenon acoustic shadows. Your vessel reaches the designated coordinates at dusk. The sea is calm, but a thin fog clings to the water's surface. The sonar technician fires up the array, sweeping the shelf edge. The first pass is uneventful, just the jagged contours of the seafloor. Then a shape appears. A vessel. Massive, its outline unmistakable. You call up its signature, expecting to identify it as a passing cargo ship. But the transponder registers nothing. No name, no ID. The contact slips along the edge of the shelf, steady and silent. You order a second sweep. Another ship appears identical in size and bearing to the first, but there is still no visible target in the water. Whispers spread among the crew. Some recall similar incidents during World War II when destroyers chased phantom convoys that dissolved into static the moment they fired torpedoes. You review the acoustic data. The returns are clean, too clean. The objects are reflecting sound with unnatural efficiency, as if built to amplify sonar rather than scatter it. Theories form quickly. One suggests that the shelf's thermal layers are bending sound waves, creating ghost images of distant ships. Another insists you are chasing echoes of the past recordings, trapped in the ocean's temperature gradients like whispers in glass. But then the contacts change course. Both ships swing inward, converging on your position. The sonar operator's voice cracks. They're moving with us. You switch off active sonar, hoping to break the illusion, but the phantom returns don't fade. One appears directly astern, the other ahead. You are boxed in. A chill runs through the crew, as every gauge on the bridge flares red magnetic compasses spinning wildly. Then for the briefest instant, the radar paints a third contact. Larger, stationary, dead center beneath the ship. The ocean feels heavy, as though something vast is rising from the depths. But nothing surfaces. One by one, the acoustic shadows fade, their outlines dissolving into the fog. Silence returns, and you're left staring at the sonar screen, wondering what happens the next time they decide not to vanish. The Bermuda Triangle. The ocean's trap. The final mission feels like a culmination of every unexplained event you've faced. The coordinates place you in one of the most infamous stretches of ocean on Earth, the Bermuda Triangle, a place where compasses spin out of control, ships disappear without a trace, and pilots have reported vanishing from radar, as though the sea itself had swallowed them whole. Your vessel enters the triangle at dawn. The weather is calm, unnervingly so. No wind, no waves. The ocean is a mirror reflecting a sky without clouds. The silence is suffocating. At first, the instruments function normally. Then the compasses start to drift, swinging aimlessly, as though they've forgotten which way is north. GPS units drop in and out. Radio calls to nearby ships go unanswered. By noon, the sonar technician detects a vast field of bubbles rising from the seabed, as though the ocean floor itself is exhaling. Methane hydrates, you think? Gas pockets destabilizing and erupting from the pressure change? In theory enough, methane could reduce the water's buoyancy, sinking even the largest ship. But then the radar screen blanks out completely. Every trace of your ship and anything else in the vicinity has vanished. You scan the horizon, nothing but empty water. A low hum begins to build beneath your feet, a vibration deep in the hull. The crew scrambles for answers, flipping breakers and checking engines, but the hum grows louder, almost like a voice. Then the sky darkens. Clouds appear from nowhere, black and heavy, swirling into a perfect circle overhead. The sea beneath you heaves violently, waves forming walls of water that trap the ship in the eye of a growing storm. Lightning flashes illuminating shapes in the mist, outlines of ships that shouldn't be there. Old freighters, wooden schooners, even planes suspended impossibly above the waves. They appear for an instant, then dissolve like smoke. Your instruments fail one by one. The hum inside the hull is deafening now. It's not just a sound, it's a pull, a sensation deep in your chest, as though something below is calling you down. For a moment, you think you see the ocean floor far beneath the ship, a perfect triangle etched into the abyss. Then, as suddenly as it began, the storm ceases. The clouds evaporate. The sea is calm. The compass is steady. You blink at the radar screen. The ship's position is exactly where it was hours ago. But the logs tell a different story. The clocks have advanced by 3 hours you can't account for. No one speaks as you turn the bow out of the triangle, but you can't shake the feeling that something let you go. You leave the Bermuda Triangle behind, but the ocean does not feel any less heavy. Its silence seems deeper now, as though it is holding its breath. The crew is subdued. No one speaks above a whisper. You try to focus on the horizon, but every wave seems too deliberate, every current too precise. Because you know what you've seen. The bloop echoing across the Pacific. The rising tones of upsweep perfectly timed to midnight. The slow, final breath of slow down beneath the Antarctic ice. The whispers of Julia, the staircases of Yonaguni, the brinicles, the phantom ships, the glowing seas. Each anomaly isolated on its own could be explained away. A quirk of nature, a trick of instruments. But together they feel like a pattern. Late that night, long after the ship's lights have dimmed, you return to the control room. The spectrum analyzers hum softly. You stare at the screens waiting for something you can't name. And then you hear it, a faint pulse deep and steady. It isn't coming from the hydrophones. It's coming from the water lapping gently against the hull. The ocean is calling again. You step back from the console, your heart pounding. Because you know in your bones that the next time you answer, it may not let you return.